Hi, I'm Qiao Song. I'm sorry to meet you like this, but as I have many final exams in the next 2 weeks, I may not be able to participate in the meeting next week. So I have to present this presentation in this form. Today, I'm going to give my understanding of description logic that I learned so far. This presentation has several parts. We will talk about what is description logic and its two main components. Then I will tell you which terms and syntax can help you to construct your knowledge representation model. After that, I will introduce the reasoner of description logic and give you an example that how this reasoner works. First, I'm going to introduce you to what is description logic. Description logic are a family of formal knowledge representation languages. And knowledge representation and reasoning is the field of artificial intelligence dedicated to representing information about the world in a form that a computer system can use to solve more complex tasks. Description logic are also the logics serving primarily for the formal description of concepts and roles or relations, which means they model concepts, roles, and individuals and their relationships. Description logic is also a decidable fragment of first-order logic. First-order logic, also known as predicate logic, is a powerful language that develops information about the objects in an easier way and can also express the relationship between those objects. In this presentation, I want to look at a special description logic, but introduce some elements they have in common. Now, we know description logic is a way to do knowledge representation. I will give you an example of knowledge representation. In this diagram, we can see many concepts such as person, man, woman, and location. And you can also find the relations between these concepts, like woman and man are both people. A company is an institute that is located in a city, and a city is a location. As man, everybody knows this general knowledge and is taught by our teachers and parents when we were children. But computers does not. So we try to find a way to teach this knowledge to the computer more efficiently and enable them to learn from that knowledge to behave intelligently like a human. To do this, we use description logic to encode general knowledge as well as this world into a model. The knowledge representation system based on description logics consists of two components, T-box and A-box. The T-box describes terminology, for example, the ontology in the form of concepts and roles definitions, where the A-box contains assertions about individuals using the terms from the ontology. To explain them in simpler terms. In simpler terms, T-box describes the words rule, such as the examples given below. Man belongs to person, woman belongs to person, city belongs to location. For all located in relationship, there must be a location existed in this relationship. You can find more rules in our daily lives, like bird is an animal, bird is a type of animal, water is a liquid, life is limited, the sun rises from the east. These are the basic rules for constructing this world, and don't don't be constrained to any single object or individual. Everyone and everything needs to follow these rules. Then what is A box? Unlike T box, A box is limited to one or more specified individuals or things. Like the following example, Mary is a person. Mary works for Company 1. Company 1 is located in New York. Mary is a woman and Mary loves John. John is a man and he loves Mary too. From these examples, we can find that T-box is describing the rules or general knowledge which is not affected by any single individual. And A-box is giving assertions which tells you which individual is following the concept or the relationship defined by the rules given in the T-box. Now, I believe you have a preliminary understanding of description logic and knowledge representation. So I'm going to introduce some terms or syntax that you can use to construct your A box and T box. Concept C denotes set of individuals, and you can also regard it as a class. In our example, the person in the person Mary is a concept, and there are many other individuals in this set of persons or class of person, like you and me. You can also understand it like the unary predicates in the first order logic. Rows denotes set of ordered pairs of individuals. Usually, it can be used to describe the relationship between two individuals, just like Mary works for Company 1 and Mary loves John. These two verbs involve two individuals, so they are roles. It has a similar meaning to the binary predicate in the first order logic. And there are many other symbols used to express more complex concepts. Some symbols are the same as them in the first order logic, such as intersection or conjunction, union or disjunction, negation or complement, universal restriction, and existential restriction. I won't explain too much about this basic logic symbol. There is only one thing that we need to notice. If A is R related to B, then B is called an R successor of A. The R in this place means the role we mentioned before. Uh, for example, in the loves Mary John. John is the love's successor of Mary. And there are some symbols that you may not see before in the first order logic. For example, uh, the empty concept symbol means this is an empty concept without any individual in it. A universal concept is a concept that contains all individuals. The inverse role symbol is used to create an inverse role or an inverse relationship between two individuals. Just like the example, the inverse loves role of Mary and John is John love Mary. Concept definition symbol can be used nearly the same as the concept equivalence. And the last symbol or the last syntax, the at most and at least number restriction syntax makes you can restrict the number of pairs in a row. This example, the example given is meaning if a people loves at least two people, then this row belongs to the empty concept. So you can find that nobody can fall into love with more than one guy. Now let's talk about reasoner of description logic. Reasoner is also called semantic reasoner, reasoning engine, rules engine. Uh, it is a piece of software able to infer logic consequences from a set of asserted facts or axioms. In description logic, asserted facts are the A box and the axioms are the T box. The reasoner also does jobs like performing consistency checking of A box and T box. For example, if there is an assertion in the A box and which said John is a man, and there's another assertion said John is a woman, then at the same time there's a rule in the T box said one people can't have two genders, then there is an inconsistency among these among the three statements, right? Reasoner also does job like finding all individuals of a concept and all concepts related to an individual. It can also perform a subsumption checking. Many reasoners use first-order predicate logic to perform reasoning, and there are two ways to do it. The first one is called forward chaining. Forward chaining is a popular implementation strategy for expert systems, business, and production rule system. Forward chaining starts with the available data and uses inference rules to extract more data until a goal is reached. An inference engine uses forward chaining searches the inference rules until it finds one where the antecedent is known to be true. When such a rule is found, the engine can conclude or infer the consequent resulting in the addition of a new information to its data. The opposite of forward chaining is backward chaining. Backward chaining starts with list of goals or hypotheses, sorry, and works backward from the consequent to the antecedent to see if any data supports any of these consequences. A inference engine using backward chaining would search the inference rules until it finds one with a consequent that matches a desired goal. If the antecedent of that rule is known to be true, then it is added to the list of goals. There are many good reasoners nowadays, like Fact++, MSPass, Racer. However, today we don't mention too much details about any one of them. In the end of this presentation, let's do some simple reasoning together. Given the following A box and T box, try to find the answer to the following questions. Because the A box is just some facts with simple syntax, so I don't want to explain them too much. Let us focus on understanding of T box first. The first rule is bachelor are unmarried men. The second means uh, means this married roles is inversible. A married B means B also married A. The third means all married people are happy. The fourth is everyone can love at most one person. The last has the meaning of someone married to a woman also loves a woman. Now we can do these questions. The first question is Sue happy? The answer is yes, because Sue gets married and all married people are happy. So Sue is also happy. The second question, let me see. The second question is, can Mary love John? The answer is no, because in the T box, we have a rule that everyone can love at most one person. And A box has told us that Mary loves Sam, so he can't love one more guy. And the last question is John a bachelor? Yes, because A box doesn't give any assertion that John has got married. So, but it tells us John is a man. And T box sets a rule that only the unmarried man is a bachelor. So John is a bachelor, right? Now I have to come to the end of my presentation. In summary, description logics are a family of formal knowledge representation languages, which molds the world in a way that the computer can understand, so that this computer can use this knowledge to deal with some more complex tasks. The description logic has two components called A-box and T-box. A-box gives assertion and facts. T-box gives rules of this world. There are many symbols and terms you needed to know to construct your knowledge representation, and you can check more details online if you want. Reasoner is the tool that the computer used to do inference based on A-box and T-box. And it can also perform consistency checking of your A-box and T-box. Okay, these are all contents of my presentation. Thank you for taking time to listen to my presentation. Thank you. Thank you very much.